The notes that we're going over today talk a little bit more about air pressure. Hopefully you saw some things in your lab yesterday that help you understand the idea of air pressure. Today we're going to go over that information a little more formally, and you can take notes on your paper as we go through. Air pressure is a measure of the force of the air pressing down on Earth's surface. So everyone lives under a certain amount of air pressure because there's air above your head, and that air pushes down on you. And when you take that force and divide by the area it covers, that's what we call air pressure. Yesterday, you saw one demonstration of air pressure called the leaky can, or stop the leak. We had a can that was open at the top. There was a small hole in the side, and the idea was to stop the leak of water by covering the top of the can. So you put the piece of clay on top of the can, and what that does is cuts off the air supply to the inside of the can, so then no more air can go into the can. The water then that was supposed to be coming out of the hole cannot go out. Hopefully you saw that when you did your leaky can demonstration yesterday. And what happens is when you plug the top hole, the amount of air inside stays the same because the outside air can no longer come in. Some of the water continues to fall out of the hole right as you plug it, right as you plug the top one, and that allows for a lower water volume inside, taking up less space. That allows the air inside to spread out a little bit, and that causes a decrease in pressure inside the can. So then what happens is the outside air pressure is greater, the inside air pressure is less, and the outside air pressure pushes against the water and prevents it from flowing out of the bottom of the can. So the bottom line here is that the air pressure outside is greater than the air pressure inside, and that holds the water inside the can. When we talk about air pressure with weather and atmosphere, we need to know that air pressure can vary. It can be different at any particular point on the Earth depending on the density of that air. Air pressure depends on how dense the air is. If we go back to our leaky can, we change the density of the inside air in the can. It spread out a little bit. That drops the air pressure inside and allows the experiment to work. So air pressure can vary at any particular point on the Earth depending on the density of the air. There are three factors that can affect air pressure by changing its density. The first one is temperature. The second one is water vapor. And the third one is elevation. All three factors affect air pressure or change air pressure by changing the air's density. Temperature affects air pressure because warm air is less dense. Molecules spread out when they're warm, so warm air is less dense than cool air. A lower density means less pressure. Elevation. Air at high altitudes is less dense than air at low altitudes. Often you hear of people describing high altitudes as having thin air. That's because the air is less dense. There's fewer molecules in the same amount of space. That means there's less pressure. And moisture is the last one. Moisture molecules get in between molecules of air and push them further apart. That has the overall effect of making the air molecules less dense, and less dense air molecules means less pressure. To measure air pressure, you need a special piece of equipment called a barometer. There are a couple types of barometers. The one you see in the picture here is called an aneroid barometer. It works by having a metal coil in the back that expands and contracts. A type of barometer that's a little bit easier to understand is a mercury barometer. This would have been the very first type of barometer. It's made of a column of mercury, kind of like a giant test tube, and you turn that column upside down into a dish of mercury at the bottom. The dish is open to the air. Air pressure pushes down on the mercury in the dish, and the amount of air pressure, depending on the day, can support or push back up a different amount of mercury into the tube. So the higher mercury in the tube would be a different air pressure than the day where there's a lower mercury in the tube. So how do you read that? How do you measure air pressure from that idea? If the air pressure is increased, the column of mercury rises. In this picture here, you can see the arrows are supposed to represent a bigger air pressure. A bigger air pressure pushing down on the mercury in the dish forces more mercury back up the tube. If your air pressure is decreasing, there's less pressure pushing on the dish, more of that mercury in the tube can fall back out. So you would have a lower mercury in the tube or a lower level here. The mercury drops. If you hear people on the weather forecast talking about the barometer rising or the barometer falling, this is probably what they're referring to. How is air pressure related to weather? High air pressure generally means fair weather, sunny weather. This is because high air pressure pushes down on the surface of Earth. That means whatever warm, moist air is present has trouble rising into the atmosphere. The pressure pushes it down. The warm, moist air cannot rise as much. If the warm, moist air cannot rise as much, you don't get any clouds. So high pressure means sunny weather. Low pressure would be the opposite. Low pressure generally means cloudy, rainy weather, because if there's less pressure overhead, that means whatever warm, moist air is present can rise into the atmosphere and make clouds. And if you get clouds, then you're going to have rain. How is air pressure related to wind? Air pressure is responsible for lots of different phenomena, including the high pressure sunny weather, the low pressure cloudy weather. It's also responsible for wind. So how is air pressure related to wind? To learn how air pressure is related to wind, let's take a quick trip to the Black Hills in South Dakota. I visited the Black Hills in South Dakota a few years ago, and I went to a place called Wind Cave. Wind Cave gets its name because its natural entrance, which you can see right here in the picture next to me, this hole in the ground right here is the natural entrance to the cave. That entrance is said to breathe. That means air comes out of it sometimes and air goes rushing into it sometimes. And in fact, all caves with a natural entrance breathe to a certain extent. This one is pretty obvious. It almost felt like there was an air conditioning vent inside coming out on the hot summer day that I was there. Air pressure inside the cave would ultimately like to be balanced with the air pressure that is outside the cave. Pressure inside would like to be equal with pressure outside. This is what causes the cave to breathe. Depending on the pressure outside, the air is either going to rush in or out of the cave to try to balance those two amounts, to try to balance the pressure inside and the pressure outside. What's kind of neat about that is you can use this breeze to predict the weather. If there's lower pressure outside the cave, then you're going to have air rushing out to try to balance that lower pressure. That means there's storms approaching. So if there's air rushing out, it's probably going to rain pretty soon. If there's higher pressure outside, that would mean there'd be air rushing into the cave to try to balance that out. So if there's air rushing into the cave, it probably means that we're headed for some fair sunny weather. So I thought that was pretty neat when I was on my vacation and I visited there. This idea of air pressure trying to balance itself out also explains wind in general. Air will flow from regions of high pressure to regions of low pressure. And that's what we call wind. That flow of air from high pressure areas to low pressure areas creates the wind that you feel almost every day. And that is the end of the notes for today. There is a quiz tomorrow over section 11.2. Please make a note card if you haven't done so already.